Hi, welcome to this lesson on Euclidean geometry, ratios and proportions. Let's have a look at question 2. ABCD is given as a parallelogram with the length of DC being 15 centimeters. The length of H, which is a perpendicular line between AB and DC, is given as 8 centimeters, so we can put that here. The line BF, so from this point on the side of the parallelogram to B, is 9 centimeters. We want the ratio of area ABF, which is this right angle triangle here, over the area of the parallelogram. Alright, so let's see how we can do this. Well, first of all, the area of the parallelogram ABCD is going to be the perpendicular height times the base. Okay, so what is the perpendicular height of this parallelogram? Well, we're given it as a little h equals 8 centimeters times the base of that perpendicular height. So the base is here at DC, which is 15 centimeters. There's going to be 8 times 15. That's going to be 80 plus 40, which is 120. And because we have a units, it's centimeters squared, or squared centimeters. Okay, next we're going to work out the area of triangle ABF. So now let's look at triangle ABF. I'm going to pull it out here on this diagram. So here's AF, right angle, that's capital H as the length, and then B, so BF was given as 9 centimeters. Do we know the length of AB? Well, this is a parallelogram after all, and we know the properties of parallelogram says that opposite pairs of sides are equal in length. So AB must be 15 centimeters. So I've got a right angle triangle with two pieces of information, so I can use the Pythagorean theorem to work out H. So H squared plus 9 squared must be the hypotenuse, 15 squared. So therefore H must be the square root of 15 squared minus 9 squared. So let's work that out. Square root of 15 squared minus 9 squared, and we get 12. So this is 12 centimeters. Okay, so the area of triangle ABF is a half the base times the perpendicular height. So the base would be FB with the perpendicular height of capital H. So it'll be half times 9 times 12. Okay, half goes into 12 6 times. 9 times 6 is 54 centimeters squared. Okay, so therefore, the ratio of the area of triangle ABF to the ratio of area of parallelogram ABCD is given as 54 centimeters squared divided by 120 centimeters squared. And you can see it makes sense to compare these two ratios because they have the same unit measurement, centimeters squared. Okay, so that means we can divide the units out because they're the same, and we just compare the magnitudes. So 54 divided by 120, and that gives me, in simplified form, 9/20. So therefore you can say that the ratio of the area of the triangle ABF to the area of the parallelogram ABCD is the same as 9/20. So as an example, if the area of triangle ABF was a different value, let's say it was 9 square centimeters, then that means if you're given the same parallelogram in the same proportion, the area of the parallelogram would be 20 square centimeters. Okay, it'll always be in the same proportion if we either scale up or scale down that parallelogram by a constant factor. Alright, so that is how we would do this type of question. I'll see you in the next one.